Hello, we're ECE Senior Design Team 6, working on the movable shelf networking for the library in the library basement. My name is Ryan Briggs.
I'm Emily Fischer.
I'm Spencer Crawford.
And I'm Josh Cribben.
And our advisor is Kit Cischke. First, let's go over the problem that we're trying to solve. The library has these bookshelves in the basement that, in order to save space, the mechanized systems will collapse them down so that a user could go in and move one shelf to the side to get access where two may be next to each other. This system is starting to deteriorate over time, and the company that did development before is now charging exuberant prices. So this project has been sent off to senior design team and an enterprise. We're working with the Blue Marble Security Enterprise to help bring this to life. Our portion, however, is focused on the interconnectivity, communication, and safety of these bookshelves. We need to answer questions such as how do the bookshelves communicate so that one can tell the others to move? What's the logic that decides this? Are there processes in place to stop the shelves if a safety hazard is present? And if it is stopped, how do we report why the bookshelf stopped to the user?
Before developing any communication solutions, we wanted to visualize just how everything would work. So here we demonstrated some inputs going through processing into outputs that could be implemented into a circuit. However, for iterability and testing, we determined that it would be best to use microprocessors for this solution. And here is a subset of that we're using to test our communications protocol, which we decided early on would be a bit line to throw high when you want a bookshelf to move and to keep low when you have no intent. And putting it all together into a physical model, here is our sample using an LCD screen to sample outputs, as well as some sample bookshelves to just test the communication before we put anything together in a physical model or on the shelves themselves.
To further demonstrate our implementation, we decided to create a moving prototype. This uses the Arduino Nanos and a Mega along with some switches and push buttons to replicate a bank of bookshelves. Here are the 3D models of the bookshelves themselves, which have a servo sitting in the middle, which then spins a gear on the track you see here, which creates the overall bank of shelves.
Along with this, we needed to implement an LCD error screen that lets the user know when a bookshelf is moving and when it stops, and also to let the user know why it stopped. We use this in testing of our software and our code, which shows how it can be used in the bookshelves themselves for the users. Here we have an example of the working model. We can see that when a button is pressed, it causes all the bookshelves to move. And when the limits are reached, the bookshelves stop trying to move. And you can also see that no matter where a user wants to access the books, all they have to do is press a button on one of the bookshelves and they will move out of the way, leaving a space for the user to go and grab their books.
Going forward, we recommend final testing. At the time of recording, we haven't been able to collaborate on a final working model with Blue Marble, so that's going to be our next and final step. Additionally, optimizing the installation of the code so it can be easily replicable to other systems. Thank you.